Next, number 2, we have if fx equals to mod of x minus 3, then find limit x tends to 3 f of x. We should know that mod of x has two values, one positive x and another negative x. So this is possible whenever x is greater than or equal to 0, and minus x when x is less than 0. So let me divide this function into two parts. So my question will be f of x equals to, see, in place of this mod of x I will write plus x minus 3 whenever x is greater than or equal to 0, and this same mod of x will be minus x minus 3 whenever x is less than 0. Now since here we can see this point 0 and in question there is a point 3, so first let me draw a number line where I will mark 2 points, that is 0 and 3. Okay, so now looking at the question, I can see that the function is x minus 3 whenever x is greater than or equal to 0. So let me write fx equals to x minus 3 here, okay, because this portion is greater than or equal to 0, and the same function f of x will be minus x minus 3. This portion is less than 0. We have limit x tends to 3 f of x, and as you know I have to find left hand limit and right hand limit. So first let me find left hand limit. Limit x tends to 3 minus f of x equals to limit h tends to 0 f of 3 minus h. Now since we were finding the left hand limit, so we were approaching 3 from the left hand, and as you see, if I approach 3 from left hand or if I approach 3 from right hand, in both the cases we have the same function x minus 3. So here my question will be limit h tends to 0 f of 3 minus h can be written as 3 minus h minus 3. In place of this x I have 3 minus h here. Okay, now let me put the value of h as 0. I will get 3 minus 0 minus 3, and finally I will get the answer 0. So my left hand limit is 0 here. Okay, similarly let me find the right hand limit now. Limit x tends to 3 plus f of x equals to limit h tends to 0 f of 3 plus h, and as we approach the 3 from right hand side we have the same function x minus 3 only, so it will be 3 plus h minus 3, and this will be equal to, now put the value of h as 0, we will get 3 plus 0 minus 3 equals to 0. Now as you can see here, both left hand limit and right hand limit has the value 0. Since left hand limit equals to right hand limit and both are equals to 0, therefore the limit x tends to 3 f of x equals to 0. So this is my answer. Number 3, let fx equals to x by mod of x when x is not equals to 0, and fx is 0 whenever x equals to 0. Show that limit x tends to 0 fx does not exist. Okay, so first here also let me rewrite the question. As you can see here, there is mod x in denominator here, so we have x by mod x has two values. It can be x over plus x whenever x is greater than or equal to 0, and x over minus x whenever x is less than 0. Okay, so let me rewrite the question. So my question will be fx equals to x over minus x when x is less than 0. As you see, the question has said x not equals to 0. So x not equals to 0 means x is either less than 0 or x is greater than 0. So actually I am dividing this portion into two parts, okay? And in second I will write 0 only whenever x is equal to 0, because that is already in question. And my third portion will be x over positive x when x is greater than 0. Now here, if you noticed, I have written x is greater than or equal to 0, but since the question has given when x equals to 0 the function is 0, so I'm not writing equals to 0 here, okay, because when x equals to 0 the function is 0. So I have rewrite the question into three parts, okay? And as you can see, there is 0 here in the question, so I'll draw a number line and mark my 0, okay? Whenever x is less than 0, then the function is x over minus x. So here the function fx will be x over minus x, because this portion is less than 0. And when the value of x is greater than 0, my function is x over x. So in this side I will have x over x. And when the x is 0, fx is also 0. So at this particular point fx is 0, okay? So my function has been distributed into three different parts. Okay, now let us start finding left hand limit. Limit x tends to 0 minus f of x equals to limit h tends to 0 f of 0 minus h. This will equals f of 0 minus h means minus h, and since we were approaching 0 from the left hand side, we have the function x over minus x. Limit h tends to 0 minus h over minus of minus h. Limit h tends to 0 minus h over plus h. Now here h and h get cancelled, so we will remain with limit h tends to 0 minus 1, and hence my left hand limit has come, that is minus 1. Now let me find right hand limit here. Limit x tends to 0 plus f of x equals to limit h tends to 0 f of 0 plus h, which will be equals to limit h tends to 0 f of 0 plus h means h only. Now since we were approaching 0 from the right hand side, so this particular time we have the function as x over x, and hence we will have limit h tends to 0 h over h, and h get cancelled, so we will be remain with 1, and my right hand limit has come 1. Now since you have noticed left hand limit has come minus 1 and right hand limit has come plus 1, and they are not equal. So since left hand limit does not equals to right hand limit, therefore limit x tends to 0 f of x does not exist. Before going to next question, let us understand greatest integer function, and it is denoted by bracket of x, and this means greatest integer less than or equal to x. Sometimes it is also known as floor function, and it is written as floor of x in this symbol also, okay? So now let us understand what does greatest integer function or floor function means, okay? So here, as you can see the definition, it means greatest integer less than or equal to x. So now here I have written some examples, so we will see. So let me draw a number line here. Here the answer of this should be that integer which is greatest integer and should be less than or equal to 5. Now if you see which integer is less than or equal to 5, So there are many integers like 5, 4, 3, 2, 1 are the integers less than or equal to 5, but among them the greatest is 5 only. So here the answer will be 5. Okay, next we have 5.1, and now which number will be the greatest integer which is less than or equal to 5.1? As you can see here, 5.1 will lie somewhere over here. Okay, now the greatest integer which is less than or equal to 5.1, okay, that means 5 only. Okay, so here this will also be 5. Now here in next number, that is a floor of 4.9. 4.9 will lie somewhere over here in the number line. Now there are many integers which is less than 4.9 or less than or equal to 4.9, but which one is the greatest among them? Obviously the 4 is the greatest integer which is less than or equal to 4.9, and hence the answer will be 4 here. And similarly for this 5.5, the answer will be 5. Now here in negative value you might get confused. First let me mark the point where will be the point minus 0.1. So minus 0.1 will be somewhere over here. Minus 0.1 will be somewhere over here. Now as you can see, my answer should be less than minus 0.1, less than or equal to. Okay, so which integer is less than or equal to minus 0.1? Yes, obviously that is minus 1. So the answer for this is minus 1. So I think you have some idea about greatest integer function. Next, let fx equals greatest integer function of x for any integer k, so that limit extends to k, f of x does not exist. First let me draw a real number line, and let us mark our number k somewhere over here. So the integer greater than k will be k plus 1, and the integer less than k will be k minus 1. So here we will find the left hand limit and right hand limit, since we have to find limit extending to k f of x. So my left hand limit will be limit extends to k minus f of x, and this will equal limit h tends to 0 f of k minus h, and this will equal limit h tends to 0. Now since f of x means floor of x, so f of k minus h will be floor of k minus h. Now here, where is this k minus h? See, h is tending to 0, that means h is very very small. Okay, so k minus h will be somewhere over here. So let me mark that point. So k minus h will be somewhere over here. Now you only see which integer is the greatest integer but less than k minus h, and obviously the answer is k minus 1. So here it will be limit h tends to 0 k minus 1, and my answer will be k minus 1. So this is the left hand limit. Now similarly let me find the right hand limit. Limit x tends to k plus f of x, that will be equals to limit h tends to 0 f of k plus h equals to limit h tends to 0 f of x means floor of x, so f of k plus h will be also floor of k plus h. Now similarly k plus h in the number line will be somewhere over here, because this k plus h is little bit bigger than k. Now as you can see in the number line, which integer is less than k plus h? Answer is k. So here it will be limit h tends to 0 k, so my right hand limit is k. Now since you have already noticed that left hand limit and right hand limit are not equal, left hand limit is not equal to right hand limit, therefore limit x tends to k f of x does not exist. Number 5, show that limit x tends to 2 x over floor of x does not exist. So first let me draw a number line and let me mark this 2. So here left hand limit will be limit x tends to 2 minus x over floor of x, and that will be equals to limit h tends to 0 2 minus h over floor of 2 minus h, and this will be equals to limit h tends to 0 2 minus h over, now see 2 minus h, where is this 2 minus h in the number line? So it will be somewhere over here, because 2 minus h is less than 2, very small than 2. Okay, the floor of 2 minus h will be 1, since 1 is less than or equal to 2 minus h. So here it will be 1, and hence put the value of h as 0, you will get 2 minus 0 equals to 2. So I have 2 as left hand limit. Now let me find right hand limit. Limit x tends to 2 plus x over floor of x, and this will be equals to limit h tends to 0 2 plus h over 2 plus h equals to limit h tends to 0 2 plus h over, now again you see 2 plus h is somewhere over here, and the greatest integer which is less than or equal to 2 plus h is 2. So here in denominator I have 2. Now let us put the value of h as 0, then we will have 2 plus 0 over 2, and that will finally give you 1. Now as you see, left hand limit and right hand limit are not equal, therefore the limit does not exist, right? Since left hand limit does not equals to right hand limit, therefore a limit x tends to 2 x over floor of x does not exist. Number 6, let fx equals to 5x minus 4 when 0 is less than x and less than or equal to 1, and the same function fx is 4x cubed minus 3x when x lies between 1 and 2. So if you draw the number line, it will be more clearer. So let me draw a number line here. As you see, when x lies between 0 and 1, then the function is 5x minus 4. So here the function is 5x minus 4. Okay, and when the x lies between 1 and 2, the function is 4x cubed minus 3x. So that means here it will have 4x cubed minus 3x. Okay, now we have to find the limit x tends to 1 f of x. So first let me find the left hand limit. So left hand limit will be limit x tends to 1 minus f of x, which will be equals to limit h tends to 0 f of 1 minus h. Now since we are approaching 1 from the left hand, so here you can see the function is 5x minus 4. So I will use fx as 5x minus 4. That means in place of x I will write 1 minus h. So it will be limit h tends to 0 5 of 1 minus h minus 4. So let us put the value of h as 0, then we will get 5 into 1 minus 0 minus 4, which will be equals to 5 minus 4, and the left hand limit is 1. Let us find the right hand limit. Limit x tends to 1 plus f of x equals to limit h tends to 0 f of 1 plus h, and this will be equals to limit h tends to 0. Now since we were approaching 1 from the right hand side, the function is 4x cubed minus 3x. So here it will be 4 into 1 plus h whole cube minus 3 into 1 plus h. Okay, so now let us put the value of h as 0. We will get 4 into 1 plus 0 cube minus 3 into 1 plus 0, and this will be 4 into 1 plus 0 is 1, and 1 cube is 1 only, minus 3 into 1. It will be 4 minus 3, and hence the right hand limit is also 1. Now since you can see left hand limit and right hand limit are equal, that means the limit exists, and the answer is 1. Since left hand limit equals to right hand limit, therefore limit x tends to 1, f of x equals to 1. Number 7. Let fx equals to cos of x whenever x is greater or equal to 0, and fx is x plus k whenever x is less than 0. So for find the value of k for which limit x tends to 0, f of x exists. Let us draw a number line. Let me mark 0 here, and let us distribute the function. So whenever x is greater or equal to 0, then the function is cos of x. So here it will be cos of x, and whenever the value of x is less than 0, the function will be x plus k. Now let us find the left hand limit here. Limit x tends to 0 minus f of x equals to limit h tends to 0 f of 0 minus h. So it will be limit h tends to 0 f of minus h, and that will be equals to limit h tends to 0. Now since we were approaching 0 from the left hand side, so our function is x plus k. So here the function f of minus h will be minus h plus k. Now let us put the value of h as 0, then we will have minus 0 plus k, which will be equals to k. Now let us find the right hand limit. Limit x tends to 0 plus f of x will be equals to limit h tends to 0 f of 0 plus h. It will be equals to limit h tends to 0 f of h equals limit h tends to 0. Now since we were approaching 0 from the right hand side, the function is cos x. That means f of h means cos of h, and this will be equals to cos of 0, and cos 0 means 1. In order to limit exist, we know that left hand limit and right hand limit should be equal. Only that time the limit will exist, and the question is saying that limit exists, so find the value of k. So here we will write, since limit x tends to 0 f of x exists. So if the limit exists, then left hand limit, that is, will be equals to right hand limit. And as you know, the left hand limit here we have calculated, and it has come k, and the right hand limit has come 1, and hence the value of k is 1. Number 8. So that limit x tends to 0, e to the power minus 1 over x does not exist. Left hand limit here, limit x tends to 0 minus e to the power minus 1 over x equals to limit h tends to 0 e to the power minus 1 over 0 minus h, and this will be equals to limit h tends to 0 e to the power minus 1 over minus h, and this will be equals to limit h tends to 0 e to the power 1 by h. Now if I put the value of h as 0, we will get e to the power 1 by 0, and since e to the power 0 is infinity, so it will be e to the power infinity, and finally the answer will be infinity. So the left hand limit is coming infinity. Now let us find the right hand limit. Limit x tends to 0 plus e to the power minus 1 over x. This will be limit h tends to 0 e to the power minus 1 over 0 plus h. That will be equals to limit h tends to 0 e to the power minus 1 over h. This equals to limit h tends to 0. Now since the power of e is negative, so I can write it as 1 over e to the power 1 over h. Now let us put the value of h as 0, then we will have 1 by e to the power 1 by 0, and this will be equals to 1 by e to the power infinity. And since e to the power infinity is infinity, so we will have 1 over infinity, and 1 over infinity is 0. Left hand limit and right hand limit are not equal, hence the given limit does not exist. Question 9. Let fx equals to k into cos x over pi minus 2x whenever x is not equals to pi by 2. That means whenever x is less than pi by 2 or greater than pi by 2, then I will use this function, and fx is 3 whenever x is equal to pi by 2. Now question is saying if limit extends to pi by 2 f of x equals to f of pi by 2, then find the value of k. Before finding the limit, let us find f of pi by 2. So here f of pi by 2 will be equals to 3. It's that simple, because the question has said that whenever the value of x is pi by 2, then the answer will be 3. See, the fx equals to 3 whenever x is pi by 2. Let us mark this equation 1. Okay, now let us find left hand limit and right hand limit, and before doing so, let me draw a number line here and let us mark pi by 2. Okay, so now let us distribute the function also. Now as you see, whenever x is not equals to pi by 2, that time function is this. So whenever the value of x is less than pi by 2, so that time the function is, and whenever the value of x is greater than pi by 2, that time also my function will be same. Okay, so now let's start finding left hand limit. So here left hand limit x tends to pi by 2 minus f of x can be written as limit h tends to 0 f of pi by 2 minus h equals to limit h tends to 0. Since this is left hand limit, we are approaching pi by 2 from the left hand. So the function is this. It will be k into cos of pi by 2 minus h over pi minus 2 into pi by 2 minus h. So it will be equals to limit h tends to 0 k into, now from trigonometry, if you know, then cos 90 minus theta. So do you know that 90 minus theta lies in which quadrant? First quadrant, and in first quadrant everything is positive, and since there is 90 degree here, that means cos changes to sine. So here we know the formula that cos of 90 degree minus theta equals to sine theta. That means it will be sine of h over pi minus 2 into pi by 2 plus 2 into h. So it will be equals to limit h tends to 0 k sine of h over, now since here this 2 and 2 get cancelled, so there will be pi minus pi, and this whole portion will be 0. So it will be 0 plus 2h, and that is 2h only. Now since k by 2 is constant, let me take out in front of limit, then it will be k by 2 limit h tends to 0 sine h by h. Now if you have not forgotten the formula, then limit h tends to 0 sine h by h is 1. So my left hand limit is coming k by 2 into 1 equals to k by 2. Now let us find the right hand limit. Limit x tends to pi by 2 plus f of x equals to limit h tends to 0 f of pi by 2 plus h, and that will be equals to limit h tends to 0. Now since we were approaching pi by 2 from the right hand side, function here is again the same. So this is k cos x by pi minus 2x. This k cos of x means pi by 2 plus h whole divided by pi minus 2 into pi by 2 plus h equals to limit h tends to 0 k into cos pi by 2 plus h. Now this is in the second quadrant, and in second quadrant the cos is negative, so it will be minus sine of h whole divided by pi minus, if you multiply and simplify, it will be pi minus 2h. So here pi and pi get cancelled, so it will be equals to limit h tends to 0 minus k sine of h by minus 2 into h. Here minus and minus get cancelled, and we have k by 2 as constant. K by 2 is constant, and limit h tends to 0 sine h by h is again 1. So here finally we will get k by 2 only. Since left hand limit equals to right hand limit and both are equals to k by 2, therefore limit x tends to pi by 2 f of x equals to k by 2, and let this be equation 2. Question has given limit x tends to pi by 2 f of x equals to f of pi by 2. From equation 2, did you see that the value of this portion is k by 2? So I'll write here this as k by 2 equals to, and from equation 1 this f of pi by 2 means 3. So in place of f of pi by 2 I will write 3. So here it will be 3, and if I cross multiply, then I'll get the value of k as 6. So this is our answer. So now with this we have completed the chapter limits. So now students, you try to solve more questions from books, examples, past years, everything. Okay, practice will make perfect. Okay, so I wish you all the best.